All right then. So today we're gonna do the Bernoulli's equations. We're gonna learn on how to use this method to determine the general solution. We went through all of the different types of techniques that we use to determine the general solutions. So now, when you talk about the Bernoulli's equations, what type of equations are we referring to? You will see most of the time when you do the applications, even for those who are studying process fluid flow, they still do the Bernoulli's equations, talks about the fluid dynamics. It's all about that. Other than that, this is what we need to understand because here we are doing mathematics. We need to understand how to solve the equations using Bernoulli's method or technique. Now, using the first order of ordinary differential equations using Bernoulli, the standard form that we always need for Bernoulli, it reads as follows. We're supposed to have the dy over dx plus py is actually equals to q multiplied by y to the power of n. And then note that n may never be equals to 1, né? Or n may never be equals to 0 because the moment n is equals to 1, we're no longer talking about the nonlinear equation of Bernoulli because we can divide both sides by y, and when we divide both sides by y, therefore this y will cancel with that y. We no longer having this standard form. Even if when n is equals to 0, when n is equals to 0, we know that anything to the power of 0 is 1, and then we're going to have 1 multiplied by q. So that means if n is equals to 0, then we're going to have the linear equation, linear differential equation. Okay, so Bernoulli, we're supposed to have y to the power of n over there. And this is what I want you to understand or take a closer look at. When you talk about the Bernoulli, it's more or less the same as linear differential equation. Okay, just have to be careful when doing this. And there are, I think, two techniques on how to treat this kind of equations, but we'll look at those two techniques and so that you can see which one is comfortable, which one you're comfortable with. Okay, so now let us start. Now, having a look at this equation, we can see that this is a non-linear equation. So we cannot use linear techniques to solve this equation. We know that when you use linear techniques, we are talking about the integration factor and we look at the value of q. But in this case, it won't work because the equation it is non-linear. So what you're going to do is on this equation, we're going to manipulate this equation to make it linear differential equation, right? So now how are we going to do that? Our concern right here, it's when we multiply our q with our dependent variable, and we don't want this. So that means you're going to have to get rid of y to the power of n by doing what? By dividing both sides by y to the power of n. So when we divide the whole equation by y to the power of n on this side of the equation, we're going to have 1 over y to the power of n multiplied by dy over dx. And then when we when we divide by y to the power of n on this, we're gonna have 1 over y to the power of, remember we are dividing by n, but because this n is at the top, when you take it at the down, it's gonna be negative y, laws of exponents. I hope you all understand that. We're gonna have negative 1 over there multiplied by p, which is this p over there, is equals to q. Honestly speaking, there is nothing special that we did over here. We just divided everything by y to the power of n. Now, again, this is what we also know when it comes to linear. We don't multiply our derivative with y, with the dependent variable. We don't want this. Still, we have non-linear equation. So now, in order for us to manipulate this further to make it a linear equation, what are we going to do? Now, this is where we're gonna let, right? What are we going to let? We are actually going to let, you can take any variable, let's pick v, or we can take u, whatever the case may be. Let's take v. We're gonna let v to be equals to the coefficient of your p, okay, which is 1 over y to the power of n subtract 1, right? And therefore, in this case, we can see that our v will be equals to y to the power of, when we take y to the power of n minus 1 at the top, our 1 will be positive, and then our n will most definitely be negative. Okay, all right. And therefore, when v is equals to y to the power of 1 minus n, what can we do with this equation? We are going to differentiate this equation, right? So when we differentiate this side, we're differentiating in respect to x, okay, which is this variable over there. So here we're going to have dv over dx, which is going to be equals to, let us differentiate this. Remember, 1 minus n, we multiply by 1 minus n as our exponent, and then we subtract what? We subtract 1. When we subtract 1, we're going to left with negative n dy over dx. Remember, we are differentiating in respect to x, okay? And therefore now, having a look at this equation, we're going to have to make y to the power of negative n multiplied by dy over dx the subject of the formula. So that means I'm going to have to divide both sides by 1 minus n. So on this side of the equation, when I divide by 1 minus n, okay, let me do this bracket. 1 over 1 minus n. Here I'm going to have dv over dx. And then this side, this will fall off, and I'm going to left with y to the power of negative n. So when I rewrite this as a positive exponent, I'm going to have y. I'm going to have 1 over y to the power of positive n dy over dx. Now, have a look at this equation again. I said I wanted to make y to the power of negative n multiplied by dy over dx, the subject of the formula, by getting rid of 1 minus n. So this is what is happening. Having a look at this side of the equation, we can see that this side of the equation, it actually corresponds with this side of that equation. And therefore, what we're going to do is we're going to substitute, right? What are we going to substitute? We're going to substitute this, which is what we see over there. So here we're going to write this. So on this side of the equation, now we have 1 over y minus n multiplied by dv over dx plus this, which is y over. Now remember, okay, that's fine. I'll just do it so that you don't get confused. The y to the power of n minus 1 multiplied by p is equals to q, right? So on this side of the equation, having a look on this side of the equation, we have 1 minus 1, this, that, dv over dx. So remember, we said that look at the differential equation. We have dv and dx. So meaning, what variables are we actually going to talk about? We're going to talk about the v variables, and we're also going to talk about the x variables. But still, in this equation, we have y variable. So how to get rid of this y variable? Remember, from the equation when we were letting, we said v is equals to y over, we said v is equals to 1 over y to the power of n minus 1. So that means where we see 1 over y to the power of n minus 1, we're going to substitute v. So that means this whole thing, it actually corresponds with v multiplied by p is equals to q. Remember, what was the aim? What was the aim of us manipulating this equation? We want to take this non-linear equation to make it a linear equation, right? Where we can use the linear differential equation starting from the Bernoulli. So now we're going to get rid of this expression over there. So how to get this? Because remember, we want to make this linear. So we're supposed to get rid of anything next to dv over dx. So you're going to get rid of this fraction, which is 1 over 1 minus n. So that means I'm going to have to multiply the whole equation by 1 minus n. So when I multiply by 1 minus n, this cancels, and then I'm left with dv over dx, right? And therefore this side I have p multiplied by v, but also because I multiplied by 1 minus n, here I'm going to have 1 minus n is equals to q. Remember what you do on this side of the equation, you're supposed to do it on the other side of the equation. We are also multiplying our q with 1 minus n. Now have a look at this, right? Have a look at this. This is what I want you to look. So we have dv over dx, right? Plus p, okay, let me just say plus 1 minus n multiplied by p, v is equals to q1 minus n. Have a look at this. Have a look at this. So here we have our value of p, and then here we have our value of q. Remember, according to linear differential equation, the standard form for linear differential equation is dy over dx plus py is equals to q, right? So when we have a linear equation like this, you know that you're going to have to determine your integration factor, know the value of P, know the value of Q, and therefore you do your methods to integrate, and therefore you'll determine your general solution. So when you have a look at this equation and this equation, we have dy over dx, but there we have dv over dx. And then remember, C is supposed to be the dependent variable. Y. Look at there, we have dv, we have vv. So that means 1 minus n multiplied by p will represent our p as it is, right? And therefore q does not matter as long as we don't have independent variable, like as long as we don't have dependent variable like here. This q, it really does not matter, so we're just going to take it as it is. This is the value of q. Now we can determine the integration factor using the value of p, using the value of p, and we know how to write the integration factor. The integration factor, which is denoted by r e this, and now we're going to have 1 minus n. We're going to have 1 minus n multiplied by p dx. This is how we determine our integration factor. Okay, so let me erase this so that you don't get confused. So we erase this over here, and then let us do it proper. How to determine the integration factor? We're going to say, remember, we denote our integration factor to be r, right? So we say our r, okay, let me start. Yeah, we say our r is equals to the integration factor, which is e to the power of integral of p. Remember our p, it is now hooked to 1 minus n. So that means just going to write it as it is. Say 1 minus n multiplied by the value of p dx, right? Remember, it's not dt, it's not dy, it's dx. So you're going to write your dx as independent variable, and therefore you determine integration factor from there. And then the value of q, we're going to take it as it is. And then from here, because it's now linear, this is a linear equation. Now this is a linear differential equation. That's why we determine the integration factor. And therefore, remember what we say. We say y multiplied by the integration factor will be equals to what? Will be equals to the integral of the integration factor multiplied by q. But be careful, our q now, it is hooked to 1 minus n. So you're going to say 1 minus n multiplied by q dx. And therefore, from there, you integrate, and then you determine your general solution. You are most definitely done. Okay? You are most definitely done. All right, so now we have a problem that we need to solve, right? Most definitely, you are given the differential equation, but with different notation, right? So the notation that I prefer is when I have dy over dx, because we can see that our independent variable is going to be x. So that means our dependent variable is going to be y. If it was 1 over t, this y prime, it was going to be represented by dy over dt. Okay, so just be careful about that. So having this expression over there, it's fine. You can work it like this, but I love changing this expression over here, this notation over there. So now first thing first, what I want to do is I want to rewrite this equation in a standard form, right? It's either I rewrite this equation in a standard form of linear, or I rewrite this equation in a standard form of Bernoulli. It really does not matter what you do. So now, what I'm going to do is I'm going to divide, because here I have y prime. So I'm going to get rid of this 2y, right? Firstly, that's what I want to do so that I can see what is actually happening. Or you can keep it as it is still fine. It really does not matter. So if I divide both sides by 2, and then I decide to leave this y over here, I'm going to have y. I'm going to have y multiplied by dy over dx. Remember, I changed this notation. Plus 1 over 2x. Remember, I divided by 2, right? 1 over 2x y squared is equals to, what is 2 divided by 2? It is most definitely going to give me 1. Okay? There is something that I want to talk about. I don't know if you're going to be able to see this. Okay? I want to go back. Don't get confused. What I did, when I divided both sides by 2, like I said, you can divide both sides by 2y. You can just divide both sides by only 2. If you divide both sides by 2y, you're gonna come here. It's gonna lead you here, okay? But because I decided to divide both sides, by only 2, it led me to this standard form. It led me here. Okay? Because eventually, if I divide both sides by 2y, it's gonna take me to the standard form of Bernoulli. Let's do it so that you don't get confused, so that you can understand what I'm actually talking about. Let's divide both sides by 2y. So that means here we're gonna have dy over dx. Plus, if I divide both sides by 2y, I'm going to have y over 2x, right? And then this side, I'm going to have 2 over, I'm going to have 1, because 2 is going to cancel 2. I'm going to have, I'm going to have 1 over y, né? And therefore, we can see that this is dy over dx, which is equals to 1 over 2x, okay? This is my y and this is my p, right? Oh, plus sign. This is my y and this is my p, is equals to 1 multiplied by y to the power of -1. And have a look at this. This is the standard form. Like I said, this is the standard form. Q multiplied by y to the power of n. N may never be equals to 1, but n can be -1. Don't forget that. So you see my n here, it's -1. This is Q. Q, it's 1. And then P, it's 1 over 2x. And then if you want to write it like this is a standard form of Bernoulli. You can use this. You can determine the integration factor using your n. It's -1. P, it's 1 over 2x. It's actually simple and quicker to do it in this way. But I love making complicated things, I guess. But when I'm here, if I want to do this, I have already divided by, remember, from here to there, I divided by y to the power of n. So that means if I divide by y to the power of -1, I'm going to get this. Okay? I'm going to get this if I divide by y to the power of -1. This is what I'm actually going to get. So it really does not matter. You just need to be careful on how to solve this. Okay? We'll do both ways, but let's start with this way first that I wanted to start with. This is a complex one and this is the easiest one, but this is the easiest one. Sometimes I don't feel like it works for other reasons, but we'll see. So now this complex one, let's start with it then. So now from here, now this is what I'm going to do. I'm going to let, remember, I follow this procedure. Okay? I'm going to let, but what am I going to let? I'm going to let my V to be equals to, remember, be careful, right? You take the coefficient of this. I'm going to let, which coefficient did we take? We took the coefficient of P, right? And in this case, our P is 1 over 2x. Don't forget that. So you're going to let our V to be equals to y squared, okay? And therefore, okay, everything is fine. We can just derive this in respect to x. So we're going to have dv over dx. And on this side, when we derive this, we have 2y to the power of 1 dy over dx. And therefore, remember, I'm going to have to make y dy dx subject of the formula. I'm going to divide both sides by 2. So I'm going to have 1 over 2 dv over dx is equals to y dy over dx. Look at y dy over dx is the same as that one, y dy over dx. And then I'm going to substitute on that equation. So on this equation, I have, okay, let me use my color. On that equation, I substitute this. So now I have 1 over 2 dv over dx, which plus, remember, what is y squared? Remember, now we have dv, right? So we deal with variable v. So we're going to take v back. Sorry. So now we said v is equals to y squared. So when we see y squared, we're now going to write v. So here we have 1 over 2x multiplied by v. I can just write it here, or we can just write it there. Multiply by v is equals to 1, which is that 1 over there. And from there, what am I going to do? I'm going to force the linear equation. How am I going to force the linear equation? I'm going to get rid of this 1 over 2. So I'm going to multiply both. I'm going to multiply this by 2, right? So that it can cancel 1 over 2. So I'm going to have dv over dx. And then when I multiply by 2 over there, I have 1 over xv, because these 2 will cancel with the 2 that I'm going to multiply with. And then this side, I'm going to have 2 when I multiply by 2. And now look at this equation. Look at the dependent variable there. Look at the dv there. Look at the q. Q doesn't have y. I mean, it doesn't have v. It's linear from here. And then from here, what do? I know my value of p, it will be equals to the coefficient of this one. Remember that it's 1 over x. And then I know that my q is going to be equals to positive 2. Now, let us determine the integration factor. The integration factor in this case is going to be integral of p dx, right? Dx, p dx. So my p is going to be 1 over x multiplied by dx, and then my integration factor will be, what is the integral of 1 over x? It's natural log of x, right? And therefore, we know that e to the power of ln x is going to be x, right? This will be my value of r, which is my integration factor. Therefore, we say v, remember your dependent variable is v, not y. We will substitute, we'll do back substitution at the end, because we said v is equals to y squared. So we can just continue here. So you're going to say v multiplied by our integration factor in this case, which is x, is equals to the integral of what? Of integration factor, which is x, multiplied by q. Our q in that case, let me take it out already, is going to be 2. And therefore here we're going to have dx. And now we have v multiplied by x is equals to, what is the integral of x? It's going to be multiplied by these 2. It's actually going to be x squared plus c. And then remember, we said that v is equals to y squared. We take our y squared back, multiply by x is equals to x squared plus c. And therefore, this will be your final answer implicitly. Right. Now we move to the second question, right? Now we are given the conditions so that we can determine the particular solution, not the general solution. Now, using this, remember, I prefer to write it in a standard form that I believe that I understand, right? Can also do that. So now in this case, this is what you're going to do. I have 6 multiplied by y to the power y prime minus 2y is equals to x. So now remember, what am I actually going to do? I'm going to divide both sides by 6, so that this side I have dy over dx minus, when I divide 2 by 6, it's going to be 1 over 3, right? So it's going to be 1 over 3y. So we have 1 over 3 multiplied by y is equals to, this side when I divide by 6, we're going to have x over 6 multiplied by y to the power of 4. There is a reason why I say y to the power of 4. It's a standard form of Bernoulli. When it's like this is the standard form of Bernoulli. Your n is equals to 4, which is y to the power of 4, your n. I don't prefer this. So what I do is I'm going to get rid of my y to the power of 4, right? So I'm going to divide the whole equation by y to the power of 4. So that means this side I'm going to have 1 over y to the power of 4 dy over dx. Subtract, when I divide this by y to the power of 4, I'm going to have y over 3 y to the power of 3, right? I'm lying. I'm going to have y to the power of, let me see. I'm going to have y to the power of, I'll be lying on that one, Shane, honestly speaking. So when you say y divide by y, it's supposed to be at the bottom, not at the top. So that means when I divide, I'm going to have y to the power of 3, right? Not at the bottom, not at the top, but at the bottom, is equals to x over 6. Now, what am I going to do? Do not forget. If you forget, write this as your standard form, okay? If you really forget, write this as your standard form, okay? This is your standard form. Okay, you take this thing, your P in this case, your P in this case is going to be how much? Your P in this case is going to be 3. Okay, it's going to be 3, your P in this case. So that means we're going to let change the color. We're going to let Y, right? We're going to let V to be equals to 1 over Y to the power of 3, right? And then now we have V is equals to Y to the power of -3. And then let's differentiate this equation. We have dV in respect to X, dV over dx is equals to, we have -3Y to the power of -4, right? We subtract 1. Remember, we're differentiating, we're not integrating. Dy over dx. Therefore, I'm going to get rid of what? Of this -3. Divide both sides by -3. I have -1 over 3 multiply by dv over dx is equals to, here, remember, this is y to the power of -4 is the same as 1 over y to the power of +4 dy over dx. Now look at this. Again, it is the same as that one. I'm going to substitute this on that equation, change the color. Therefore, we're going to have, on this equation, we substitute -1 over 3 multiply by dv over dx, subtract. Remember, our v is equals to 1 over y to the power of 3. So that means our v is going to be the same as 1 over 3 multiplied by v. Okay? Because we can say 1 over 3 multiplied by 1 over y is the same thing. So be careful. Make sure your algebra is on point as well. And therefore, there we have x over 6. Look at this. We're just going to get rid of this -1 over 3, multiply by the whole equation. We're going to multiply it by -3, right? When we multiply by -3, we're going to have dv over dx. Then we're going to have positive v, because we're going to multiply by -3, multiply by -3, multiply by -3. Then we're going to have negative x over 2, right? Then this is linear. Independent, dependent variable, dependent variable. Q, remember, Q could be constant. Q supposed to have the independent. It's fine if it has independent, not the dependent. We don't want Q to have the dependent, so we are happy. It's either constant or it's either the independent variable. Now we determine the value of P in this case. We know it's going to be, the value of P in this case is going to be 1, right? Remember, Py, here it's PV, so the value of P is going to be 1. And then the value of Q is going to be the whole thing, which is negative x over 2. Therefore, let us determine the integration factor and say R is equals to e to the power of integral of P, which is 1 dx. And therefore, we have e to the power of x. We bring x back, right? When we integrate dx, we bring x back, right? Therefore, we know that we're going to say our dependent variable, which is v, multiplied by integration factor, which is e to the power of x, is equals to the integral of what? Of integration factor, which is e to the power of x, multiplied by q, which is negative x over 2, d what? dx. Therefore, from here, we have v e to the power of x is equals to, let's see what's happening. We can take -1 over 2 outside of the integral sign. And then we have x multiplied by e to the power of x dx. Therefore, how to integrate this? It's simple. You know, you have many different ways to integrate. Can use U substitution, okay? We're going to use U substitution to integrate this. It's not U substitution. We're going to use the by parts. We're going to use by parts to integrate this, okay? How to use by parts, you can use the detail method. Let me erase this side. Don't have space here. Okay. So we're gonna use by parts, and we know how to use by parts, right? Using by parts, we can use the detail method or the old way to do by parts. So when you use by parts, we're gonna say, okay, we're gonna say detail. We use detail, right? Which comes first? Is it algebra or is it the exponential? So when you say detail, exponential comes first, so we don't even have to stress ourselves. So we're gonna pick it to be the one that we're gonna integrate. So here we're gonna have v prime. This side is gonna be e to the power of x, and therefore that means our u in this case is gonna be what? It's gonna be x, which is the algebra. And then here we have the sign. We know that we're gonna start with positive, and then let's differentiate this. It's gonna be 1, then there's negative. Let's integrate that. Integrating that is gonna be the same throughout, right? We differentiate this until we get 0, have positive again, till we get 0. And then here we integrate, it's still gonna be the same thing. Therefore, we take the diagonals, right? So now let's write this as it is. So we have v e to the power of x, which is equals to, here we have -1/2. So now let's go. Take the diagonals, x multiplied by that one, it's gonna be x e to the power of x, and then -1 multiplied by this one. Oh, be careful. Okay, let me do this because we have negative outside of the bracket, ne? Okay, let me just write it like this. And then we're gonna say this one and this one negative, and that one is gonna be negative e to the power of x, this one and this one, right? And then we take the integral of 0 ex is gonna be 0. We can just leave it as it is, but the only thing that we need, it is the constant, which is c. And therefore, we have v e to the power of x is equals to, let us distribute. We have a -1/2 x e to the power of x. This is going to be +1/2 e to the power of x plus c, right? And therefore, we do back substitution. We know that we said our v was equal. How much was our v? How much was v? Please remind me, I erased.
Isn't it y to the power -3?
Okay, so we said our v is y to the power of 3. E to the power of x is equals to -1/2 x e to the power of x plus 1/2 e to the power of x plus c. Implicitly, this will be our final answer. But because, we're given the condition, remember, we're given the condition, so we need to solve for c. Now, to solve for c, what are we going to do? X is equals to 0, and then y is equals to -2. So when x is equals to 0, and then y is equals to -2, we're going to have 1 over, here we have -2 to the power of 3, and then here we have e to the power of 0 is equals to, so this one is going to be 0 because x there is 0. Here we're going to have 0. And then here we're going to have 1/2 because it's going to be e to the power of 0. It's 1. And therefore plus c. I'm just being quick here. Time is about to end. And therefore here we have 1 over -8, right? Which is 1 over -2 to the power of 3. It's going to be -8 is equals to 1/2 plus c. We transpose 1/2 on this side of the equation. We get our c as a numerical number. We substitute c over there, and then we have the final answer. Okay, so the time is going to cut me. Therefore, that will be our